This is a video for the final review in my Calculus 1 class. The directions say to find the derivative. So let's take a look at 3c. We have y equals x squared plus 1 to the fourth divided by 2x plus 1 to the third times 3x minus 1 to the fifth. So from here, what we're going to do is take the natural log of both sides. So natural log of y is the same as natural log of x squared plus 1 to the fourth divided by 2x plus 1 to the third times 3x minus 1 to the fifth. And so what I want to do is simplify the right side a bit more. So natural log of y is natural log of, and this is x squared plus 1 to the fourth minus natural log of, and then it's 2x plus 1 to the third times 3x minus 1 raised to the fifth. And then from here, we can say natural log of y is 4 times natural log of x squared plus 1 minus, and then within these brackets, I'm going to write natural log of 2x plus 1 to the third plus natural log of 3x minus 1 to the fifth. From here, I can say natural log of y is 4 natural log of x squared plus 1 minus, and then within the brackets, I'm going to pull the 3 out and write 3 natural log of 2x plus 1 plus, and then doing the same thing here, I'm going to pull the 5 out in front and write 5 natural log of 3x minus 1. Now, distributing that negative through, we can say natural log of y is 4 natural log of x squared plus 1 minus 3 natural log of 2x plus 1 minus 5 natural log of 3x minus 1. Okay, from here, we can differentiate very nicely. So we get 1 over y dy dx. So we're differentiating both sides with respect to x. That's the left side. On the right side, we get 4 over x squared plus 1 multiplied by 2x for the first term. That's chain rule. Minus 3 over 2x plus 1 times the derivative of that inside, which is 2. Minus 5 over 3x minus 1 times the derivative of 3x minus 1, which is 3. Okay? So from here, we can say 1 over y dy dx equals. Now, I'm going to get 8x over x squared plus 1 minus, and then I'm going to get 6 over 2x plus 1 minus, and then from here, 5 times 3 is 15, so I get 15 over 3x minus 1. So dy dx, multiplying both sides by y, is y times 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 over 3x minus 1. Now I just have to substitute in y. So dy dx is x squared plus 1 to the 4th divided by 2x plus 1 raised to the 3rd times 3x minus 1 to the 5th. Okay, that's y, times the rest of it, which is 8x over x squared plus 1 minus 6 over 2x plus 1 minus 15 over 3x minus 1. And that's how you do 3c. Let's take a look at 3d. Suppose I had f of x equals x times arctangent x minus 1/2 natural log of x squared plus 1. So believe it or not, this one simplifies really, really nicely. So if I want f prime of x, on this first term, I'm going to apply the product rule. Now, the derivative of x is 1. So I'm left with arctangent of x, right? Plus x times the derivative of arctangent of x, which is 1 over 1 plus x squared. I'm going to go minus 1/2 times 1 over x squared plus 1 times the derivative of that inside function, which is 2x. The derivative of x squared is 2x, right? And so this is arctangent x plus x over 1 plus x squared minus x over 1 plus x squared, which is equal to arctangent x. So therefore, f prime of x is arctangent x. And that's how you do 3D. 3e. Suppose I have y equals e to the x secant x plus secant of 1 plus x squared plus natural log of the absolute value of secant of 5x plus tangent of 5x. And I want the derivative. So I want dy dx. Now, let's take the first term. So I'm going to get e to that power, in other words, e to the x secant x times the derivative of x secant x. Well, that's going to be secant x, because the derivative of x is 1, plus x secant x tangent x. That's the first term. And then, given the limited space, I'm going to have to go to the next line to take the derivative of secant of 1 plus x squared. The derivative of secant of 1 plus x squared is secant of 1 plus x squared tangent of 1 plus x squared times 2x. So that's chain rule. Okay. Then I'm going to go plus, and then we got to take care of this third term. So that's 1 over secant of 5x plus tangent of 5x, right? But then I have to multiply by the derivative of what's inside. So I need a little bit of room here. And so I'm going to get secant of 5x, tangent of 5x. Let's try that again. Tangent of 5x times 5 plus the derivative of tangent of 5x is secant squared of 5x times 5. Now, this third term can be simplified a bit, and we'll do that on the next page. So dy dx is e to the x secant x times secant x plus x secant x tangent x plus 2x secant of 1 plus x squared tangent of 1 plus x squared. Okay? That's the second term. Plus, now remember, what I'm going to do is factor out a 5 secant of 5x. And when I do, I get secant of 5x plus tangent of 5x divided by secant of 5x plus tangent of 5x. And I want you to watch what happens. So if you notice, this secant of 5x plus tangent of 5x in the numerator cancels that secant of 5x plus tangent of 5x in the denominator. And so I would want to see that, okay? And so dy dx is e to the x secant x times secant x plus x secant x tangent x plus 2x secant of 1 plus x squared tangent of 1 plus x squared plus 5 secant of 5x. And that would be fine for a final answer. There's really no common factors between the three terms. And that'll do it for this video, where we looked at problems 3C, 3D, and 3E for the final review. Okay. All right. Thank you.